Where were you at when you saw it?
Outside.
Outside where? At what time?
Alrighty.
Oh yeah, you're just slow.
So we finished our discussion about the moons of Jupiter, and they were pretty neat and stuff. But let's be honest. If we're looking at the solar system and we want to visit a place that looks really, really cool, there's no other place we're going to go than Saturn. So let's head there right now. Yes. So we have moved on to Saturn, the gassy planet. It apologizes. Jupiter was stormy planet. Yeah. Because of the big red spot.
Gas.
So there's good old Saturn with its rings. A little bit about its history. Go ahead and write down the first bullet point here, please. The first one. So Saturn is the last planet that is easily visible from Earth. As we get further and further out, on a perfect night with perfect vision, you'd be able to see one or two others, but they're not going to be easily visible. Saturn is the last easily visible one, and it moves slower in the sky than all those other planets. So this is a picture of Voyager 2, I believe it is, as it goes by Saturn. It's artistic representation, obviously, because this is what would actually be taking the pictures. But yeah, it visited Saturn in the 1970s, and we got our first close-ups of it back then. It also went by the rings, which was pretty interesting. A lot of fun things we're going to learn about the rings of Saturn today. This is the sort of thing you'd see as we get down to the clouds of Saturn, and this would be the ring going around it there. From this, go ahead and write down that it is a gas giant and that there is no solid surface. Look at this picture for another couple seconds. I like it because it's very accurate. The cloud color is accurate. This is about the amount of stars you'd see from the surface there. And the ring, I mean, that's about what the ring would look like if you were hovering just above the cloud tops of Saturn, like we are. And a little bit about those clouds. They're made up of ammonia crystals. Go ahead and just do the first bullet point here. This is all pretty much review because it's the same stuff that Jupiter's clouds were made up of. Just the first bullet point, yep. Now, Saturn is a very, very big planet, just like Jupiter. It's not quite as big or dense, but it is massive when you compare it with the size of the Earth and the other planets. So the question might be, when you look at Saturn, it is definitely not nearly as colorful as Jupiter was. So why do we have that lack of color? And the reason is because of the sulfur in the atmosphere. Sulfur is an orangish, yellowish color, and if you've got too much of it, it can really dominate the color spectrum that you see on a certain planet, kind of like Io. Its surface is very sulfuric. That's why it looks so ugly and yellowish. Saturn's the same way. It looks orangish and it looks yellowish because of all that sulfur. This is on your handout. What I would like you to put a little arrow next to on this would be this piece of information here. Most storms are relegated to 35 degrees south. Also put a little arrow next to the wind speeds there.
God.
Yeah. Yeah. So, just like on Jupiter, you would sink down into Saturn's surface. So just like on Jupiter, because, to take some measurements and get some temperature measurements, I need to figure out a spot where we're going to define its surface. And we're going to define that surface the same place we did with Jupiter, where the pressure is the same as the surface of the Earth. But storms on Saturn are all mostly located at about 35 degrees south. And they call that Storm Alley. If you go to Saturn and you pick a spot that you don't want to try and land, it would be in Storm Alley, because there's all sorts of storms in that area. Lightning 10,000 times as powerful as Earth's, and wind speeds 1,120 miles an hour. That's almost Mach 2. So when you're talking about these wind speeds, remember Jupiter had wind speeds that were consistent. Keep it down a little bit, guys. Jupiter had wind speeds that were consistently at 400 miles an hour, which sounds like a lot. But look at this. It's almost 3 times as much. So Saturn really has some strong winds, and it's not even the windiest place in the solar system. I'll tell you this much. Either this information or this information will be on the quiz. One of those two numbers. So that's why I had you point those out. It's got a very thick atmosphere. You'd probably guess that because you don't see very far into it. It's got very thick clouds. Nice little picture there. In the same way that Jupiter has the Great Red Spot, Saturn has something known as the Great White Spot. And occasionally you'll see this in the northern hemisphere. And a couple interesting characteristics about this Great White Spot. It's essentially a big hurricane, just like the Big Red Spot is on Jupiter. As far as this information goes, you don't need to write any of it down, but some kind of interesting bits here. This occurs about every 30 years or so. It's seasonal, because Saturn takes about 30 years to go around the sun once. And so when it gets to a certain time of year, this storm kicks up, and it gets very, very violent in the cloud tops there. And it gets so violent and so big that it can encircle the entire planet. This is one of the areas of Saturn where it actually looks a little bit like Jupiter. Remember how Jupiter kind of looked like a big watercolor painting? If we zoom in on this great white area here, it looks kind of like a water painting too. So that's at least some parallels we can draw between those two planets. Now, Saturn isn't just about this big white hurricane, and it's not about Storm Alley, 35 degrees south. There are other storms on Saturn too. Go ahead and write down the first bullet point, please. Nope, just the first bullet point. So if you find yourself in our spaceship and you're looking at Saturn, and you know it's either the North or South Pole, if you see this hexagonal storm, you know that you are at Saturn's North Pole. And this is actually an animation. I think it only goes when I first click the slide. So I'm going to go back and you can kind of see it moving. And you can see it kind of rotating there. So it's a gigantic hurricane that's just going around the North Pole of Saturn. Another image of it right there, kind of zoomed in. Looks like a what? Sure. Some more zoomed in images right there. So this indicates that we are near the North Pole of Saturn. But of course, if we're going to talk about Saturn, what's the biggest feature about Saturn? The rings, absolutely. So the rings of Saturn, we got to talk a little bit about these guys. These are just images taken from different positions and different locations looking at those rings. This is from the underside. This is not an actual picture. This is an artistic representation. The last one was a real one. Yes, this was taken by one of the Voyager spacecraft as it flew by.
Wait, so it's like that's Saturn?
Yeah, this is Saturn, and the sun, of course, would be over here somewhere. And kind of like that picture where Jupiter was backlit, and that allowed us to see the single ring. This one shows these rings in a little bit more detail than what we would normally see. And you're able to see this ring, which is not clearly visible if you're looking at Saturn normally. So you can see all sorts of things that you wouldn't normally see when the sun's on the opposite side of these places. Yeah. So, we could blow up the moon, then we'd have a ring. So we've got the rings of Saturn are made up of these big chunks of ice. And the first time people saw the rings of Saturn was in the 1500s. Got that one wrong. Yeah, 1500s, Galileo was the first to see the rings. This is on your handout. You don't need to point anything out on this handout. But it is kind of interesting that when he saw it, you know, back then telescopes weren't nearly as advanced. But he could tell there was something on the sides of Saturn. And he thought that they looked like ears, and he thought that they were just moons that were stuck on either side of Saturn as it orbited. And they were first identified as actual rings in the 1600s by a little bit more powerful telescope by Christian Huygens there. From this slide, write down the first bullet point on the left here. So the reason I have this slide in the background here is because I want you to be able to see that when you're looking at the rings of Saturn, they don't look like this. They're mostly ice or ice-covered rock. You're not going to see rocks that look like rocks. They're not going to be dark. They're not going to be brownish. They're going to be whitish, something like that. So this would not be an accurate picture of what Saturn's rings look like up close. They're less than an inch to several yards across. So these are rather large in terms of the material that make them up. Most of them are closer to an inch, so that would make this drawing kind of wrong as well, but you get the idea. And if we zoom in, and this is not a real color image of the rings, this is something where they changed the colors just so that you could kind of see all the different little ringlets that go around Saturn. It's not one gigantic ring. It's literally between 50 and 100 little ringlets make up this entire system. And you can see them a little bit more well-defined in this picture here. Now, of course, when we zoom in and we see these rings, there's this space in between most of those rings, and we've got a special name for that. Just like in the asteroid belt, the spaces between the asteroids were called Kirkwood gaps. This one we call a Cassini division. So label Cassini division. Make sure you know that's the space in between some of the rings on Saturn. So Cassini division is just a space between the rings as they go around Saturn there. And this is a neat picture. It doesn't look like much, but this is a mapping of the Cassini division as it was done by a spacecraft, as it actually got this close and was able to map it out very accurately. You can actually see, this is a star called Pan, that you can see right through that gap. So, and they mapped out with computers where the other ringlets are that you can't really see all that well. Another picture there.
How long is this?
I'd probably say a couple hundred miles long. Maybe a little bit longer even. Especially when you consider how big Saturn is. Yeah, so that size is much bigger than that's probably a couple thousand miles across. From this slide, you don't have to write anything down. 9 times the size of the Earth, so it gives you an idea of scale here. Yeah.
What's the diameter? Does it include the rings or
Just the sphere. And you could fit 763 Earths inside Saturn. Now the next slide, I've kind of been skipping over this slide a lot in the other planets. This is the one that has to do with average density. See if you can figure out what this number means and why it's important for Saturn. Anybody put it together? So Saturn has an average density of 0.69. I've briefly talked about what density means and how it really compares to other planets. It's definitely less than 1. And what is... water is 1, absolutely. And that's where I was hoping you guys would go with this. So if the density of Saturn is less than 1, what does that mean? It floats, absolutely. If you got yourself a bathtub that was extremely large and you plopped Saturn in there, it would float. So you can go ahead and write this down. That's the sort of thing that you'll find in trivia contests. Anything that's less dense than water will float, and Saturn is no exception. Yes. Aside from this, also write down that the average density is less than water. Average density less than water. Kind of reminds me of my little guy. One of his favorite things to do is crawl into the bathroom, and he likes to go over to the bathtub, and we've got these little toys that he plays with in there, and they're hooked to the side. He loves to grab those toys and just chuck them in the bathtub and giggle. He just thinks it's the funniest thing. And I say, John, what are you doing? Don't you do that. And he just laughs, and he hits the side of the bathtub. I love that little guy. So, a couple spatial measurements here. You can skip this, but one thing that you want to kind of keep in mind, well, first off, this is a really bad picture because this is not how big the sun would look from this distance. It's going to look much, much smaller. but it is the 6th planet from the Sun. We are about 10 Earth-to-Sun distances away, and the orbital speed is down to 6 miles per second, which is still, booking it. You're going pretty darn fast at 6 miles per second. But does anybody remember how fast Mercury was going? Fast, like 30 miles per second. So as you get further away from the Sun, your speed in orbit decreases substantially. Write these down, though.
So when it orbits the sun, is that the point when it orbits the sun? Is that when the storm is going to happen?
Yeah, it's at a certain, I don't know exactly what points, because Saturn actually sort of has seasons like Earth because it's tilted. And so whether it's when spring would start on the northern hemisphere or when summer would start on the northern hemisphere, there's one point on its orbit there, where that storm will kick up. Yep. That's something that I might look up. That's kind of interesting. So it spins on its axis in 11 hours. Now, what's interesting about this number is it's a very small number. It takes a very short amount of time for Saturn to spin around once. So that means it's spinning very, very quickly. And just like Jupiter, when Jupiter, because it's a big gas ball too, it bulges out at the sides because it's spinning so fast and it's not very dense. Saturn is going to do the exact same thing. And I don't remember in my head if it wins the award for most eccentric shape because it's bulging out at the sides. But if it doesn't, it's really, it would probably be second place. So because Saturn spins so fast and it's very not dense, it bulges out at the equator quite a bit. And it orbits the Sun every 30 years, so obviously it's going to take a long time for you to turn one. Temperature at 1 bar, negative 308. So it's really, really cold at the cloud tops. That's what you got to take away from that. And now that we're getting further and further away from the Sun, we're going to get less and less of a temperature difference from the cloud tops to the quote-unquote surface. The surface temperature on Saturn is negative 218. So it's 80 degrees or so warmer, which isn't that much in the grand scheme of things here.
What was the last one?
Yeah, you don't have to write those down. I'll let you know what to write down. So it's kind of interesting, but now that we're getting so far away from the Sun that these numbers are getting closer, they're kind of less important. So Saturn also has a magnetic field, just like the Earth, just like Jupiter. So it's got that going for it anyway. Slightly weaker than ours, and it's not made the same way as Jupiter and Earth's magnetic field is made. It's not the sort of thing that would be consistent. It changes quite a bit over time. So when you look at this picture, just kind of know that it has a magnetic field. You don't have to write any of this down. It's not as strong as Jupiter's magnetic field. But one of the cool things about magnetic fields, like we talked about before, when you've got them, you're going to have a pretty neat light show at your poles. And Saturn is no exception. This is, I guess, what you would call Aurora Borealis at the southern end of Saturn there. This is the same thing at the northern end. These are made the same way as they are on Earth and on Jupiter. You've got the magnetic field, and that magnetic field interacts with the solar wind from the Sun, and that solar wind finds its way into the atmosphere of Saturn, where you get this little light show going on at the poles. Another question might be about Saturn, is there ice or water there? Yeah, there's a little bit. There's some in the clouds, and there's a lot of it in the rings. And that's actually one of the best pieces of evidence that show that Saturn is not super, super old. And I'll I'll save it for when that slide gets here. In terms of this slide, go ahead and write down that there's lots of ice in the rings. Now, in terms of Saturn's composition, it's very similar to Jupiter, which means it has a lot of hydrogen. Hydrogen is the most prominent element in the entire universe by far, and most of these gas planets are made up primarily of hydrogen with a little bit of helium. From this, go ahead and write down the order. Do this whole bullet point here. I'm having you write it down because it shouldn't be that hard to remember. It's all hydrogen. It's just different types of hydrogen as you go inside. So you just got to remember gas, helium droplets, metallic, and then you've got your solid core. In other words, if you just remember you're going from not very dense to dense, you'll probably be just fine. Oh yeah, yeah, super, super hot. I couldn't even really give a good guess. Tens of thousands, or probably tens of thousands of degrees, somewhere in there. What's that? In Kelvin? I'm not sure. But yeah, so in terms of Saturn, as you're descending and as the pressure goes up, it's no surprise that you go from gas to liquid to solid to more solid. So in terms of gravity, even though Saturn is much larger than the Earth, you're only going to weigh a slightly bit more. And the reason for that is because it's very sparse. It is not a dense place. And again, gravity has to do with how much material is actually there. And because Saturn is big and not very dense, it really doesn't have that much more material, that many more molecules or atoms than the Earth does. And so the gravity is roughly the same. You can jump 2 feet on Earth, you'd be able to jump just a little bit shorter on Saturn. And you can see again, if the sun looks this big from Earth, it's going to look like this from Saturn. So it's really starting to lose its disk shape now. It's just starting to look like a real big bright star. It would still hurt your eyes if you stared at it, but it's getting noticeably smaller. You can only see Saturn at nighttime. It is not bright enough to be seen during the day. If you do see it at night, it's going to look like your standard yellowish star. And it is the last planet you can readily spot without a telescope. I think that's one of the first things you wrote down. So yeah, this is a picture you can kind of see and compare. Saturn would look about this bright compared with the surrounding stars. So generally it looks brighter than the surrounding stars, but it's not even close to anywhere near the brightest thing in the sky. With a telescope, if you get it at a good angle, you can see something like this using the telescope in the back of the room. If you don't have as good a telescope, or if you're looking through binoculars, the rings are going to look kind of like ears. Now there is a chance, actually, if you don't, because Saturn goes through seasons. It goes through different tilts. And so there's actually a possibility that when you look at Saturn, if it's pretty much dead on, you might not even notice that it has rings. Because there's a point at which those rings are exactly in line with our plane of view. And that's the worst time to see Saturn because you don't even see the rings. What was that?
I don't care about Saturn, I just care about the rings.
Yeah. From what I remember, I think it's in a really good spot to look at rings. And that's something we're going to look at in the Astronomy Club. Again, you're welcome to come to that observation. I think it's October 23rd. It's a Friday, a student help day, that we're going to go outside and look. If you want more information, let me know. So, how does the sky look on Saturn? This is on your handout. You don't need to write this down or point anything out, but it is blue, and it turns yellow as you begin to descend through that sulfuric atmosphere. At night, it's black, obviously. If we have our sacrificial freshmen and we kick them out, their fate will be death by wind. The wind is just so strong, and even if you don't land in Storm Alley where it's over 1,000 miles an hour, maybe you land in a relatively calm place where it's 500 miles an hour. When you go in there, you're going from 0 to 500 like that. Oh, that was bad. Like that. And so when you do that, you're going from 0 to the speed of sound that quickly. You're going to get shattered, whether you're in a spacesuit or not. You can write this slide down. So Saturn's rings are not in a stable orbit. They are unstable. Over millions or billions of years, they would not be in existence. You would need to have a very precise orbital speed that these rings have to have as they continue to go around Saturn in the same way that satellites orbit the Earth. It has to be at a very precise speed. And they're unstable. They're not at that exact speed. They can stay there for a while, certainly not millions or billions of years like they supposedly have been around since the beginning of the solar system. Furthermore, the ice in the rings is extraordinarily clean. When we take samples, there are very little, if any, imperfections in that ice. And what you would expect to see if these rings had been around for that long is you'd expect to see a lot of space dust, a lot of micrometeorites in your samples. But we hardly see any, if at all, when we find these samples. And the rings should be much more dirty than that. Also, in your notes, write down death by wind. Forgot to have you write that down. If you land on Saturn, the wind's going to kill you.
Imagine trying to land a spacecraft in 1,000 miles an hour.
Yeah, it's like impossible. Absolutely impossible. Because even if somehow you put the thrust just right so you were going 1,000 miles an hour in the opposite direction, you're not accounting for any change in wind, you know? You could be going down just right, and then the nice crosswind of Mach 2 comes at you, and then you're shattered. So just a few other things I want to mention with Saturn. There is one more thing that you need to write down with it, and you'll have time to do that. But it's more stretched out than any other planet in the solar system. Looks like I was right about that. And when viewed from Earth, sometimes its rings seem to disappear for the same reason that I told you before. Saturn has different tilts. Sometimes it's tilted like this, where we get to see all those rings in all their glory. Sometimes it's tilted head-on, so you don't hardly see anything at all. Go ahead and write down what Saturn wins here. Most eccentric shape, that means it bulges a lot at the equator. Best lightning, It's hard to beat 10,000 times more powerful than the Earth. Best rings, of course, and least dense. Yes, that floats.
How much stronger is the wind on Saturn?
Well, Jupiter, I think, was 40 times Earth. So whatever 10,000 divided by 40 is. So 1,000. Still like 1,000 times stronger. And for what it's worth, Saturn comes in second place for a few things, too. Quiz on Saturn tomorrow.